Good evening, everyone, and welcome to the third webinar of the webinar series on Lean Six Sigma. So we have today the same speaker you met last week and the week before. That is Dave. Dave Hauff is from GELRAD in Europe. He is speaking live from London. We also have all the four founders of GELRAD with us. We have Elaine speaking from Florida. We have Ram also from the US, Praveer from Connecticut, and Dave is live from London. Navrachana University in Vadodara has tied up formally with GELRAD to offer such training and consulting for very high-end programs and high-end services. Especially in the area of lean management, agile, and such management and technology related areas. So we will have the third session today, which is on Lean Six Sigma tools. So thank you once again for joining all of us in today's session. And on behalf of Navrachana University, I'm Dr. Nilay Yagnik, and I thank you once again.
Thank you very much, Nilay sir. And I once again welcome all the participants. Friends, those who have missed the earlier two sessions on Introduction to Six Sigma and Introduction to Lean Management, we have uploaded a YouTube video on YouTube where you can see this. From those two sessions, we had received a lot of queries, questions, which was largely addressed by Dave during his session. However, we also received a query from some of the participants that are you going to organize some program where we can learn something hands-on. And to address that, we have planned a Lean Six Sigma Yellow Belt certification program in the last week of August and first 2 weeks of September. It's going to be 12 days, 2 hours each plan. Our instructor are Mr. Ram and Mr. Praveer from GELRAD. It's going to be online Zoom, and we'll be issuing the e-certificate from Navrachana University and GELRAD. And this is going to be a paid program with rupees 3,000 per person for Indian participants. With that, I would hand over the session to Mr. Dev. Dev, please go ahead.
Welcome to part 3 of 3 for our Lean Six Sigma series. This one we're going to cover actually the tools, the Lean Six Sigma tools in greater detail. This is the third time I'll have introduced myself, so I'll again make it very brief. My name is Dave Hauff. I am originally from the US, but I have been working in the UK now for the last 23 years. My background is originally in nuclear engineering. That's what I studied in school. I worked for GE for 10 years. That's really where I learned about problem solving. And, excuse me. And I've been working with my colleagues in GELRAD now for almost 20 years. And again, looking after Europe, Middle East, and Africa. It's kind of my area of responsibility. As we said today, this is Lean Six Sigma tools and concepts. This is our third one. But really, this is just the beginning. As we just heard a moment ago, there's some additional training that you can get involved in. And really, that will be the opportunity for you to learn a lot more about the concepts and the tools, and then find a way to apply them in your day-to-day work and life. Because really, that's the way you learn anything. So the actual knowledge, we create awareness in these webinars, but the knowledge really goes in when you get a chance to try it out for yourself and practice it. So that's my suggestion to you. The methodology, so just a quick reminder of where we are in terms of the method. So this is our Lean Six Sigma approach. It combines the variation reduction approach of Six Sigma with the waste elimination of Lean. The tools you'll see are used interchangeably throughout the methodology. We don't really have there's the Lean approach over there, and there's the Six Sigma method approach over there. We really operate them together as one holistic approach. So at the beginning, in the define phase, be really clear what the problem is that we're trying to solve, and we'll spend a bit more time on that now today. Who the customer is, what are their needs and their requirements, and then also what's in scope and what's out of scope for the project, who's on the team. And then in the measure phase, let's go get some data and let's see what is actually happening. in the process here, and establish that current state with facts and with data. So from a process perspective and from a data perspective, what's really happening here? Excuse me. And then in the analyze phase, let's use some of the data that we got in the measure phase to help us understand the reasons why the problem is happening, so we can get to those validated and prioritized root causes, so that then when we get to the improve phase, we're putting solutions in against the root causes and not just against the symptoms we see when we first discover the problem. So we'll spend a little bit of time talking about one of the tools that's helpful for that as well. So once I got the solution in place, and it may be multiple solutions, let's verify in the control phase that it really is better and that it's going to stay that way. So what actions do we need to take? What are our responsibilities? And we'll look at one of the tools around how you can understand what's going on with that ongoing monitoring. And then share the lessons learned of what we learned throughout this project, both from a project and perspective and a process perspective. Because that's our methodology. The tools that we're going to talk through today, the tools really are there to put structure to conversations you're probably already having. And we get together, we talk about our problems, we try to understand what's happening, we talk about what to do next. Really the tools are here to put structure to that conversation. So you'll have a better conversation, it's going to go faster, and you're going to get a much better result coming out the other end. And that's really what the tools are there for. It's really rare that I would be in a coaching session with someone and they would say, "That's crazy, Dave. Why would we do that? It doesn't make any sense." All the tools are pretty straightforward in terms of what it is they're trying to achieve. And what they're trying to do is to help you go faster and do a more effective job of what it is that you're doing. So you get to a good answer and the right answer in the least amount of time. The tools that we've got, they do kind of fall into just a few categories here. If you look at what the tools are trying to help you achieve as you do these conversations, there's quite a lot of them that are about process and data analysis. A lot of the tools are there. Let's map the process. Let's do some calculations. Let's make some graphs. Let's run some analysis and so on. There's a lot of the tools there to help you measure, understand, and improve that current situation and have the data, those metrics to do the before and after sort of comparison. And that's a lot of where we're filling in gaps in knowledge or capability for people, is that maybe we didn't learn these, or you learned them in school, you never used them, but you did okay on the test to get through and get your degree, and then you never use them again. So a lot of these things may look familiar when you get a chance to actually use them, and it'll make a whole lot more sense because now you're using them on something that's truly meaningful to you, a problem you need to solve yourself. So a lot of the tools are really around that process and data analysis. Some of the tools are there to help you around alignment and clarity as a team. So things like the problem statement that we'll look at in a minute, clarifying what's in scope, understanding what the customer needs are. That's there to really gain knowledge and get the team aligned and agreed around what we're working on. Many of them are there also for idea generation. So these are brainstorming tools, and we might use those at the start when we're trying to figure out what specific problem to focus on. We may use it when we're brainstorming possible causes. We may use tools when we're trying to work out solutions, and even some of them are there to help you just be more creative or think more completely or more broadly about what it is that you're working on. It's probably worth a comment here. Like there is no official set of Lean Six Sigma tools that exist. If there is an approach or a mindset or something that's out there that is useful and helpful to solve the problem, we grab it and we pull it in and we use it. And so there's stuff that you may see in here that you recognize from other experiences you've had, and that's because it was useful, and so we've included it in the methodology here. There are several tools around prioritization and decision making. So how can we evaluate a variety of alternatives in a more data-based approach rather than necessarily a who talks the loudest, who has the strongest opinion, or who's the most senior person in the room? Can we put some data and some numbers and some facts to the decision so I'll get the best decision and with the least amount of time and effort? So things like the filtering matrix to take a couple criteria and filter out a large number of options, or even a tool like Rapid, which is about the roles in decision-making. Who is the one person who has the decision-making authority? There are tools around engaging your stakeholders. to make sure that you're bringing them along with you on the journey. A lot of times the reasons projects fail is because we haven't brought the stakeholders with us. They don't like the ideas that we're putting forward, or they don't want to help and contribute because they don't see the value. So we have tools to help with that as well, because it's not just about getting the right answer. We got to make sure the humans agree and are aligned with this. And then there's of course several tools around just the execution of the project to be efficient about what we do. Stuff that you might recognize as normal project management thinking and approach. So we've got a project charter, we have issues and risks and things like that. Plus Delta is a way of regularly evaluating what you're doing, like the meetings that you may be having as a team. What are all the things that went well in this meeting that we want to make sure we continue? Those are the pluses. And then Delta meaning change. What are all the things that we would change and do differently, so the next time we get together, we're going to have a better meeting? You know, so if you do that regularly, and that's really true of anything you evaluate regularly, it will get better with time. You know, so if you can take action on those and save some time at the end to evaluate your meetings, the team meetings will get better, the project will go faster, and so on. So these are kind of the broad categories that the tools fit in. There's no way I'm going to be able to teach you all of these in the next 45 minutes or so. So what we're going to do is just hit on a few of them that will be perhaps the most fun or interesting, or perhaps these are the most important ones worth digging in a little bit deeper in. The rest of them you'll get to see through the additional training, the yellow belt training, and if you choose to progress beyond that, some of the more sophisticated tools in green belt, black belt, and master black belt. Okay, so let's have a look at the define phase. So I moved through this slide quickly when we did it 2 weeks ago in the first webinar. I'll spend just a little bit more time here on that. So we have tools around picking the right project and problem, and we will spend a bit more time with the problem statement. But the is-should matrix is there to help you brainstorm all the possible things we could be working on. Because often when you get started, it's not clear what we should be working on. You know, the leader comes along and says, there's some issue with invoicing. You guys need to go sort it out, you know, and we get in a room together for either 30 minutes or 60 minutes because that's how long meetings are. And then we talk about it for that period of time. And then at the end, somebody writes 2 or 3 things down. The is-should matrix is a tool to put some structure to that brainstorm so that, as I said, it's going to be a better conversation, it'll go faster, and you'll have a more complete and thorough output coming from that. And so once we've sort of identified that, we can write a problem statement, we can put it on a project charter that has the rest of the information that we'll discuss and agree with our sponsor around what we're going to work on. So what's the constraints and assumptions, maybe some issues and risks, who's on the team, what are our timelines, and so on. And then there are several tools around scope, what's in scope, what's out of scope. A visual way of laying some of that information out is a tool called the scoping tree, where I can narrow my problem down to smaller pieces, but still see the connection back to the main business priority that I may have started with. SciPack is a tool from a process perspective that helps me around a number of things, looking at what's in scope for the process I'm looking at, as well as the customers I'll need to talk to and some other stakeholders I'll engage. We have some tools for understanding the customer needs, voice of customer, engaging with them, analyzing what they say through Kano analysis, and then formalizing what we think their critical to quality requirements are. And then, as I said a moment ago, tools to get started around engaging stakeholders. You will see these on the rest of the phases, because stakeholder engagement is not just something you do at the beginning. You'll do that throughout the project, because if you don't, when you get to the improve phase and you want to start making changes, you're going to regret it. Because people won't be with you on the journey, they won't want to make the change. And so we'll get started now, and we'll carry that on through the project. I think I may have said this last time. Nobody gets to the end of their project and says, you know, things would have been better if only we'd had more graphs. Nobody ever says that. It's always about the stakeholders. I really wish that I'd figured out who these people were, and I'd engage them and involve them in the project from the beginning, so that then when it was time to do something or make a change, they understood the reasons why. Okay, and then as I said a few minutes ago, getting ready to manage the project, let's get a plan in place. Let's make sure that we know who's on the team, what our roles are, any issues and risks, and there's several other things there as well that we could look at. Okay, so the one we're going to focus on here from define and spend a little bit of time on, we're going to get to do a quiz in a few minutes on that, but I have to introduce the subject first, is the problem statement. So I've got here a couple of problem statement examples that I just want you to have a look at here for a second. So I'll read through them. So the first one says, from September to December 2017, 4.9% of invoices led to the creation of a credit note. This results in a delay to receive revenue with an impact on working capital, a reduction in efficiency while the team rectifies the problem, cost of raising the credit notes, and customer frustration. And when I use this slide all the time when I'm doing training, and I always ask the group, give me some feedback on this problem statement. What do you think about it? And one of the first things I almost always hear is, oh, that's far too long. You know, I couldn't possibly read 2 whole sentences, you know, in a row. It'd be really difficult to tweet that. You know, I think it might fit with the increase in characters that they did a couple of years ago. But most people's initial reaction to that is it's too long. There's way too much stuff in that. I'm not even entirely sure what problem I'm solving because we're talking about credit notes, but also delays of revenue and working capital and so on. And then often people, I also ask, what do you like about it? And people will say things like, well, I like that there's a number in it. So I see that this is roughly a 5% problem. So that gives me an idea of how big or bad the problem is there. I know something about the time frame of what's happening here. Oh, I don't think I changed that one to 2019. Oh, goodness me. By the way, these are both real problem statements. The first one's been around for a long time. I always try to update the numbers to be relevant so people don't complain, oh, this problem statement's so old. I think I did it on 2 slides from now, though. So yeah, there's always a lot of feedback, things people like and don't like about it, but often they're very critical of sort of what's there. You know, how much does it cost to raise a credit note? Could I measure customer frustration? Well, what do I do with that? And with the second one, from May to July, 30 to 40% of customer orders in product line C in region A took longer than 7 days to deliver. This has resulted in a 25% increase in complaints, a cash flow impact, and damage to our reputation. And in general, people kind of, after looking at the first one, they say, oh, I kind of like that second one better. Certainly it's shorter. That's nice. We like that it's quite specific around it being product line C and it's region A. So we're being very, very particular about the customer orders. They don't like usually so much that it says 30 to 40%. You know, maybe we don't actually know. So, you know, when you're writing a problem statement, if you know, put the number. If you don't know, at least give me some kind of a range. You know, if you don't know at all, stick a blank. But is this a 30 to 40% problem or is this a 3 to 4% problem? That actually matters in terms of how I will look at the problem and engage with it. And again, people usually comment, oh, how much cash flow are we talking about here? Is that a $2 million problem or a $20 million problem there? So generally the people say, well, there's okay stuff here, but often it's a lot of criticism of things that we think could make better. And definitely both these problem statements have ways we could improve them. But they're actually not that bad in that they have the things that we want and they don't have the things that we don't want. So good problem statements have these 5 pieces. And I showed this one 2 weeks ago, and we had a short discussion around problem and cause and solution and how we tend to mix up our words around that. And the example we used was around weight loss. You know, and the problem is I'm fat, and a cause might be that I'm eating a lot of carbohydrates, and a possible solution is going to the gym. And we talked about why it's important not to include those in the problem statement. So I won't repeat that conversation now, but I want to talk a little bit more about the 5 pieces that we're looking for in a problem statement. So the first one, object. So the mental model that I always have when I'm thinking about this is there's a conveyor belt. We're manufacturing something in whatever this process happens to be, whether it is a physical process or an electronic one, like producing invoices and so on. And so things are moving along the conveyor. Things are moving through the process. What are those things? What are those objects that are moving through? And okay, the first one's going invoice number 1, invoice number 2, and they're kind of going by me. And then I pick them up and have a look at them. Okay, so this one's actually okay, nothing wrong with that one. Second one along, this one looks like it has a defect. There's a failure here to meet a customer requirement in some way. It may well have more than one. Okay, so there's something wrong with this one. There's a defect here. There's a mistake happening to this object that is here. Okay, so that one was bad. Next one along, that one's actually okay. Next one along, that one's bad as well. Okay, and this is now starting to tell me about the extent of the problem. How big or how bad is it? How many, what's the number? What's the percentage? How many of these things, these objects are having these defects? And then, so what? So this thing has a defect. So what? Does it mean that I have to throw it away? Does it mean that I have to do some work to fix it, like some rework? Does it carry on through the process? It gets to the customer sees it, and we have to apologize, give them a rebate or something like that. What are all those downstream impacts or consequences of some number of these objects having these defects? And then what's the time frame that goes with this? So is this a new problem? Is it an old problem? Or often how this is used is what's the time period of our sample? So from this time period to that time period, it was some percentage of these things that had defects which led to these horrible consequences. That's what we're looking for in a problem statement. So if you look at our two examples that we've included here, in the first one, the object is the invoices. The defect is that they led to the creation of a credit note. Okay, so there's of course lots of other ways invoices can be wrong, but specifically the one we looked at in this project was about the credit notes. And there's also ones that could lead to debit notes, right? So the credit notes, we've overcharged the customer. Debit notes, we would undercharge them. The customers tend not to mention those quite as often as the ones when we've overcharged them. So that's the defect. Something was wrong with this invoice that led to a credit note. The extent was 4.9%. And actually, it would be useful to know, is that 49 out of 1,000? Is that 490 out of 10,000? Can I put a number to that as well so I can get an idea of the magnitude here? The impact is the whole second sentence about the revenue and the working capital and so on. And again, we'd like to have some numbers on those things. And then the time frame they looked at was the 4 months from September to December. And you can see I've fixed the year in one place and I did not in the other one. So yeah, there's ways we can improve these, but actually they're not that bad. The pieces are there. It doesn't say why the credit note, there's no cause stuck in there. It doesn't say what a possible solution is. That isn't there either. And so it may feel a bit long, but actually it's complete. It has the things that we need. I'm sure there's a way we could maybe write it a little bit better, maybe even make it a little shorter and neater. What tends to make problem statements long is that impact piece of it. That's often where it gets big. And then if we look at the second one, the object is the customer orders of product line C in region A. That's the thing that's moving along the conveyor, order number 1, order number 2, and so on. Defect is they took longer than 7 days to deliver. The extent was 30 to 40% of them. And again, I'd like to see a number with that as well. The impact is the whole second sentence about the complaints and so on. And it'd be useful to have some data there also. And the time frame was May to July. And ideally, actually, I would like to know what year that is, because this problem statement may be around for a while. Okay. Actually, the very first one on the top, that actually was originally from 2007. I've used this problem statement for a long time. Okay, so that's our model. And what we're going to do now is we're going to practice. We're going to practice with this. So this is going to be your turn. We're going to run a survey in just a second. The survey is going to have 5 questions, and this is a chance for you to practice the learning from the last 5 minutes. And I've got obviously the 5 pieces of the survey are going to ask you with just multiple choice questions, multiple choice answers, what are each of the 5 pieces? Okay, so the problem statement here is, in 2019, 8.3% of customers in Germany were unprofitable, costing the business over 2.3 million euros in lost margin and use of resources on unprofitable customers. Okay, so we'll run the survey now. We'll let it go for about 30 seconds. What I would suggest is don't overthink it. Don't overthink it. It's not, we're not trying to trick you here. So go ahead and, Dinesh, if you can please run the survey, and then I'll try not to distract you too much while you guys answer the question.
The survey has been launched. There are 5 questions. Please go ahead and select the options.
Okay, and I'll just run a timer here. Okay, that's been about 30 seconds.
Dave, just a few more seconds, please, because
Sure.
right now only 7 out of 31 have
I
posted
was
their
just about to ask you where we were with the timing, so we can go longer. It's absolutely fine.
Yeah. So now 10 out of 30, 31.
Well, if we can get up to 15, perhaps, then maybe
Yeah,
that's it.
sure.
Yeah, and again, don't overthink this. Go with system one, your reaction, and then we can have a look at the results when we sort of get to that number. And for those of you watching on YouTube, I'm sorry you can't participate in the survey.
Yeah. We have now around 19 or 20, I think. Yeah.
Okay. That's probably enough. So please go ahead and close the survey and we can have a look at the results.
Yeah. Just give me a minute. Yeah, there.
Fabulous. Okay, so question number one was, what is the object here? 58% of you chose the customers in Germany, which is indeed the correct answer. That's the thing that's moving along on the conveyor. Customer number one, customer number two. Oh, and by the way, it's the German ones. German customer number one, German customer number two. Quite a few people also chose costing the business over 2.3 million euros in lost margin. Sometimes people sort of choose that because we mix up the word object with the word objective. So what is my objective? Well, it's actually to save that money that I'm wasting here in lost margin. So it's not uncommon for that to happen. But really what we've got moving through the process, the thing that's going through is a customer. And then the defect, question number two, what is the defect? It's that they were unprofitable. And again, 53% of you chose the correct one that's there. What is the specific failure or the defect that's happening to each one of these customers? So I've got a German customer and most of them, 11 out of 12 of them are profitable, but 1 out of 12 of them are unprofitable. Okay, so that is the defect there. The extent is the 8.3%. So this is question 3. And 53% of you got that one. That is indeed the correct answer. That's the count. How many of the customers were unprofitable? Oh, it's 8.3% of them. Sometimes people choose the 2.3 million euros in lost margin because that's a number as well. There's a measure there that we can say, well, it's a 2.3 million euros of lost margin. That's how bad the problem is. Really, we want the number for the extent to tie directly to the count of the defects. How frequently is that happening? So the impact is the 63% of you chose that it is indeed the 2.3 million euros and the use of resources on unprofitable customers. So it's not just a direct margin issue. There's also an indirect cost there that we're spending on the humans that are getting involved in this. And then lastly, the last one, 89% of you got the time frame in 2019 is indeed, that's the year that we looked at in total. In fact, originally this one was 2008. This one's also quite old as well. So pretty good there. I think in general, the wisdom of the crowd's work there. We chose, and on all 5 questions, the most frequently chosen value was indeed the correct one. And this is a thing that don't feel bad if you didn't pick the right one on every question, because nobody ever does, right? It's one of these skills where we know all these words, these 5 words here, but we've just given them a new definition in the context of writing a problem statement. And so we all have to relearn them. And that's myself included, by the way. So when I first did my Greenbelt training in 1998 in GE, we were taught something around problem statements, but it was not this. It had pieces of this, but not all of this. And then it was about 10 years ago that we sort of innovated this, and this is better, and I find it's much easier now to write good problem statements knowing these pieces, but it takes practice, and as even though I've been doing this for a very long time, Nobody ever writes the perfect problem statement the first time, and that's me included, right? And I'm an engineer, and we never speak in absolutes, okay? But nobody ever laughs at that joke, but I do it for me anyway, because I think it's funny. Nobody ever writes the perfect problem statement the first time, myself included. You will always look at it and think, oh, I could probably clean that language up a bit later, or go take a break, come back to it tomorrow. Or even actually, this was years ago, I was teaching a course, and this was in retail. And I had just 3 people for this project. We were sort of facilitating and training at the same time, and just working on the project. And so we were working in someone's office. She was away on maternity leave, so the 4 of us had her office, and we had stuff up on the walls. And it was one where the leader just came in and said, go sort out all the in-store signage. So in this retail environment, all the signs that are not directly related to the products there. So where are the lifts, and where are the stairs, and where's the cafe, and all that. There's a whole process around getting this stuff printed and shipped and so on to the stores. And the leaders, the sponsor said, go sort out all the in-store signage stuff. And so we didn't really know exactly where to get started. So we used the is-should matrix, which is the tool I mentioned earlier on brainstorming possible areas to work on. And we had at least a dozen problem statements that were all sort of written up on the wall. And then this was multiple days we were doing this workshop, kind of working together. And so we went home. We all came back the next day, and 2 of the flip charts were gone. And we realized what had happened in the night was the blue tack, or the tape that we had used, had let go, and the pages had fallen to the ground. It just so happened that's right where the bins were. And so the cleaners came in, that stuff was sitting on the bin, they picked them up and they threw them away. And so at first we were like, oh, I can't believe this has happened. So then we had to look around and realize what's missing. And then we took another 20 minutes or so to rewrite them. And all 4 of us agreed they were better. So having had a good night's sleep and thinking about it again the next day, we wrote a better, shorter, cleaner problem statement than what we had remembered from the day before. And this, of all the things that we do in the training, of all the tools, I always tell my groups, this is the #1 most important thing. You've got to have a clear direction of where you're going. And I think I said that put that quote up in the first one there. Is if you're not pointing in the right direction, you can run as fast as you won't get to your destination. Okay, so the problem statement as a tool is really helping you gain alignment. Let's make sure we as a team understand and agree what we're working on, as does our sponsor, as do all the people that we're going to work with. Okay, and you may have heard this one before, and I can close the poll now. There we go. A problem well defined is a problem half solved. Okay, so if you can get yourself organized and aligned around what the problem is, everything else in the project hangs off of that. And I see it happen with projects where they spin. If they can't quite get the problem statement right, it can take weeks or sometimes even months to really get clarity of what it is we want to work on. And a lot of times that comes down to being clear about what is the defect we're trying to fix. Okay, we spent a long time on that one as a tool, and that was deliberate, again, because of all the things we cover. I think it is, in my experience, the most important one to get right, because as I said, everything else sort of hangs off of that. Okay, thanks for participating in the survey, and well done for that one as well. Okay, so measure. What's the current state of where we are? So we've got quite a few tools here now that fall in that first category around getting some process and data analysis done. So what is that current process? Let's make a map. Let's look at the value stream map like we did last time in the lean session. What data do we have to get? And we have some tools to help us, things like the P diagram, help us think about what information do we want to gather when we start going to get data, and what stratification factors will be helpful so that later I can start to cut and slice the data. And how will I be sure that I have good data, good operational definitions, so that when I measure and you measure, we're going to agree. So this morning I had a call with Japan. It's a project around purchase orders being created and actually having them finally approved and signed off after the service start date. So really you're supposed to have that done before the vendor starts working, but for various reasons, there's delays to the process and the vendor's getting started before we actually have the purchase order set up. And so the team now is going to go out and start talking to people who have had these after the fact purchase orders. And they're going to ask them why and try to drill into the details. But before we start making phone calls, let's get together and think about what the questions are we want to ask and what kind of responses would we expect to get, and how would we classify them, so that then when people start telling us stuff, we've got 5 or 6 people doing this, the data from 5 or 6 people coming together will actually all join up. And though you categorized it as this over here, and I did it over here, and we actually did really mean the same thing. Because that's what some of those preparation collection things are. Measurement system analysis. Make sure my measurement system is good enough to get data. Otherwise, I might have variation in the measurement system, and I won't be able to see the variation in the process, because it's all coming in terms of how we gather the data. It's that noise is blinding the signal I'm trying to see. Okay, and then we can establish the baseline, put some numbers to it, a lot of different tools there, looking at defect metrics, of various ways of measuring the process. Some of that we talked about already with the extent. What is the cost of poor quality? So when I do have these defects and these failures, what does it cost me in terms of hard costs of actual money, in costs of people's time, in lost opportunities, even the missed out to have additional sales and revenue generation, those kinds of things. And then once again, engaging and updating our stakeholders. Again, we're going to see those throughout. So the one that we chose to look at in slightly greater detail here is one that you may have some familiarity with, which is simply a simple swim lane process map. So we saw a value stream map from the lean world last time. Here's another way of looking at the process. And this one has the process organized by swim lanes. And hopefully you can see that this looks a lot like an Olympic-sized swimming pool. Ooh, Olympics would have been happening right now in Japan. There might even have been some swimming happening as we were doing this. And each swim lane represents the person or the organization who does the activity there. So you can see with this map, we've got the customer at the top, and that is generally the convention. Start with the customer at the beginning of the process in the top left there. And then map the steps and show who's actually doing it. So who's the first group that the customer interacts with? Well, that's customer service when they place the order. Okay, so that activity is happening, but I'll move it to a new swim lane so I can track all the things that customer service is doing. And then I can see all the things that demand management are doing and so on. And it takes up more space, on the page to be able to do this. But it's really worth it because I get a lot of wonderful things from this. So first of all, I get to see the ownership and the accountabilities that are happening there. And that's actually really helpful. In fact, I've got a story for that in just a minute. I can certainly see any bottlenecks, right? So if I have a particular lane where there's an awful lot of steps and tasks in there, that might give me a clue that this group or this team is a bit overloaded. Maybe if this process is taking too long and that's the problem we're trying to solve, it's because it's going into this black hole of this one group, and then they've got a bunch of things to do, and everything's happening in a very serial kind of way rather than having some parallel processing. So I can see those bottlenecks there. I can see the dependencies, so it's not just the next step along in the process. I can see that if I don't do things right in the beginning in customer service, that may impact not just demand management, but manufacturing later on when they're making the products, or even storage and handling when they're preparing the order. So you can kind of see the dependencies between the different groups as well. And of course, anytime I cross a lane boundary, that's a handoff. Anytime there's a handoff, there will be a delay, and there's a chance for a defect. So if I have to give it to somebody else to do the next step, there's a chance I'll do that wrong and I'll fail to pass the right information. And certainly there's gonna be some kind of delay. It may be short, it might be a brief electronic delay or something like that. But in general, every time there's a handoff, it's gonna slow me down in the process. And so again, if you're trying to make things go smoother and faster and you see a bunch of handoffs there, that's a clue that maybe I should start combining some responsibilities here. Maybe it would be better to have more things in one team to get rid of those handoffs. Okay, but I can only do that once I go get a true picture of what really is happening. And there's various versions of process maps. There's of course what we think it looks like. This is the one that we probably already have documented. It's in a manual or it's up on a shared drive somewhere. And that's a nice big list of what we don't do. Because if we were doing things like that, we would have no problems because the process map looks great. It doesn't say that the supplier shows up late and doesn't bring the materials, or the materials are out of spec, or people turn up late to the meeting. And none of those things are in there in the process map. It's sort of documented perfect state there, which is a lot like people's CVs, right? When you make your CV, the CV doesn't say shows up late to class, you know, eats noisy crisps in the corner and things like that. All that stuff isn't in your CV there. And the same things with our process map. So we have what we think it looks like. The lower left of the green, that's what we wish it would look like. And it's smoother and faster and fewer steps and so on. But the one we really need to make any progress here is the big mess of what it actually looks like. That's what you've got to get in the measure phase. And we're going to need that again later when we get to the improve phase, where we're going to change things and make them better. I've got to know the current state with all the mess and all the ridiculous things that are happening. Otherwise, there's no opportunity for improvement. And that can be uncomfortable as well, because when you start to interact with people, engage with them to get them to change and do something different, they may not want to tell you the truth of what's actually happening there. You may not get the reality because they don't want to get in trouble. They don't want to share with you that they do make mistakes, or it may not even occur to them to tell you that. So wherever possible, it's best if you can go see it actually happening. You know, go to the place. One of the words that in the lean world, a lot of them are Japanese. I think I've mentioned that before. Gemba, which is go to the real place. That's really what that means. It's the same word they actually use in crime scene investigation. Let's go see what's really going on there. So that's kind of what we need there. And I do have a good story around that. This was several years ago with a chemicals manufacturing company. They were having issues around maintenance and just the time it was taking to get jobs done and backlogs and so on. And so we got a big group together. We couldn't actually map the whole thing end to end by watching it, but at least we got the groups together, the main groups that were involved. And there were various other people as well, but largely the group of about 20 of us were these three groups. So you had the engineers who decided, here's the things here's the maintenance that needs to be done, right? So we own the equipment, we know the schedules in terms of how they degrade with the exposure to chemicals and so on. So we know what needs to happen here. So they would say what needed to be done and according to what schedule. You then had the planners sitting in the middle there, and they would do the detailed planning of the many jobs that would be going on every single day all around the plant to make sure that the equipment was there, the scaffolding, the tools, all that sort of stuff that was needed. And then you had the technicians who actually perform the work. And so we started mapping the maintenance process from the initial need to do something to it's all finished and signed off. And by the end of the day, we had about 100, 120 post-it notes on this big bit of paper up on the wall. And a lot of great insights that happened during the day. But my favorite was at one point in the middle, one of the engineers said to the planners, he said, so you guys in planning, what you do next is this. And he said something. And the team leader of the planner said, we don't do that. And the engineer said, no, this is what you do, and proceeded to tell the guy his job. And the team leader, he just started laughing. And he said, that's not what we do. And here's why. And the short version of the story is that the engineers were doing more detailed planning around the jobs than was necessary. And their detailed plan didn't take into account the fact that there may be other jobs happening in that same area. So detailed plans around tools and scaffolding, it wasn't necessary because that's what the planners do. That's the work that they do, is to make sure all this stuff is organized. And so the engineers were doing a detailed plan that the planners were not even looking at. That's what they said. We don't even look at that. I know you guys do it, and thanks, but we don't even use it. And so we made the decision in the workshops. The engineers just said, well, we just won't do that anymore. It saves us time. We don't have to do it, and you guys aren't looking at it, so it's less stuff we have to hand to you, and everybody wins. Okay, so that's what you've got to go see. Get up from your desk and go see what is actually going on. Find out, because that creates the opportunity for the insight. It's not uncommon for process mapping to happen where, especially if you involve a big consultancy, they send in an army of people, they all do one-on-one interviews with the people involved in the process, and then they put the puzzle pieces together. It's okay, but you miss out those opportunities for the dialogue and the conversation. Think, hang on a second, is that really what you do? You know, and it might happen when you review the finished map, but it doesn't happen in the same organic kind of way. Okay, so that's just a bit on process mapping. Again, if you participate in the GELRAD training, you'll get a chance to talk a lot more about that, and you'll get a chance to do it on your own project. Okay, I'm going to keep moving just to keep the time going here. So the analyze phase. A lot of tools here around understanding why the problem is happening. So we've got some tools for identifying possibilities, and these are brainstorming tools. cause and effect diagram, 5 whys. These are things to help me think about what could be causing the problem. Then I've got some tools around looking at the process in a systematic sort of way, measuring the time. What's the probability of getting through right the first time? How could things go wrong? What are some of the defect failure modes that could happen there? And then, of course, there's plenty of graphical and statistical tools. I didn't bother mentioning the names of them all here. And then also hypothesis testing to be able to validate. So it looks like that's meaningful, but can I prove that mathematically and statistically that is important? So I can then finish with my prioritized list of root causes and keep my stakeholders engaged. Okay, so the tool I've chosen just to talk for a couple minutes about is a tool that you may have heard of before. This one is called the 5 whys. This is a tool that where it does what it says on the tin there. And what I mean by that is it's right there in the name. So when you're trying to understand why something's happening, just keep asking why and do that until you get to something that looks and feels like a root cause. So it might be 5 times, it might be 7 times, it might only be 2 or 3. So the example that is here is the scenario is that you get home from work, it's dark, so you step in the house, you turn on the lights, but nothing happens when you flick the switch. Why is that happening? What are the possible causes for this? And then you do a brainstorm and get the team together. So could it be something to do with the bulb? Okay, well, why would we have a problem with the bulb? Oh, the bulb is broken. Well, why would the bulb be broken? It was hit by a toy. And of course, there could be lots of other reasons. I could have bumped the bulb with a ladder when I was working. Maybe it was the light was turned on and I splashed water on it, so it cracked the glass. Like, there's a lot of different reasons why. So at every level, you could have multiple whys, multiple reasons why this is happening. So why would it be hit by the toy? Oh, because the child's playing inside. Why is the child playing inside? Because the grass is too long outside. Okay, and that's the idea of the 5 whys, is to drill down beyond the initial level of causes. And there's a course that we used to do for technicians in the oil industry working up in the North Sea. And their leaders wanted them to be better at root cause brainstorming and root cause analysis, right? Because these are technicians who would do repairs. And so there's a pipe or something that's failed. They would go out and they would replace the pipe, and then they would get on with their next job. But their leaders want them to be better at understanding why, so that then maybe we can prevent it from happening again. And so we get these guys in the course, and of course, none of them want to be there. They're all prisoners. Oh, I haven't explained prisoners to you guys, right? So when I do sessions, I tend to get 3 kinds of participants in the sessions. So we get prisoners who were told to come. Okay, someone made them come to this training. They don't really want to be there, but someone made them go. We get tourists who think, hey, this kind of sounds interesting. I could take a break out from my day job, maybe get a free meeting sandwich or something like that out of it. And just check and learn a bit more, see what it's like. And then we get learners, so people who actually know what the course is about, and they've actually come maybe even with some specific problems they want to solve. So all these guys, and it's mostly guys, they're all prisoners. They don't want to be there. And so we introduce this scenario at the very start of the course. We introduce the scenario after just some brief introductions. And then the question is, tell me the root cause of why this problem's happening. And then we let them brainstorm for a few minutes, and they write some stuff down, and then they go back to sitting there with their arms crossed, waiting for this to be over. And then I ask them, okay, so tell me what it was that you came up with. And all I ever get is the first level of stuff that you see on this chart here. The bulb was missing or broken. The breaker tripped. The power was out to the house or the street or whatever, right? The wiring is somehow damaged. That's all they ever say, and then they stop, right? And none of those things are root causes, because I can ask why on every one of those things. And then what we do is, so we teach them the tool. I can give them evidence cards. You can see in the lower left, we've got suggestions around remedial actions, improvement actions, and so on. And if there's an investigative action, what that means is, if I thought this was true, how would I investigate to find out? So if you look on the far left, if I think the power's out to the street, an easy way to figure that out is to just look at the neighbor's power and have a look out the window. If their lights are on, we know that it's not that. All right, so if they list some investigative actions that they've done that, I've got a card that says, oh, yeah, you check the neighbor's power and it's fine, right? So we guide them down this scenario where if they, at some point they say they're going to inspect the fitting, that says on the right side here that the bulb goes into, I've got a card that says you discovered corrosion. right? And well, why is there corrosion? Well, generally water has to be involved. Why is there water there? Well, could be rain, could be a leaky pipe. Okay, here you go, you found a leaky pipe. Why is the pipe leaking? Well, because it cracked. Why did it crack? Because it was frozen. Why did it freeze? Well, because we put the pipe in a location where it could get cold and we didn't insulate it there. And in the end, for the scenario we've given, that is the root cause of why the problems happen. And when we do the initial brainstorm at the start of the class, nobody ever says, oh, leaky pipe in the wrong place there, right? That never comes out of the initial brainstorm. And that is the power of the 5 whys. It is meant to take you beyond that surface level. All right, so what we share this with them as well. When you discover a problem, the way we sort of notice it usually is there's a symptom, right? There's an alarm that's sounding. This is a real example that's here as well. There's steam everywhere, right? That's what gets noticed there. This may well be the impact in the problem statement. And then we go and do a little bit of investigation. We discover a problem. There's a failure or something that's happening there. And in the example that's here, there was a pipe that was broken. There's a crack in the pipe and it was leaking and steam was gone. So they shut everything off and let it all cool down and found the crack. And so what they did is they went and they replaced the pipe. Like, there's a crack here, it's damaged, so we'll go ahead and replace the pipe. And then they turned everything back on. And about 3 days later, the alarm went off again and steam was everywhere. So they turned it all off, let it cool down. They saw there's a crack in the pipe in the same place. And instead of just replacing it again, they went and did some further investigation. They kind of traced it all the way back through the system to discover that in the end, there was a junction box somewhere that this is in a wet environment, right out in the North Sea and that. So there's a wet environment so that rain can get on. So the junction box has a rubber seal around it to keep the water out. But the seal had failed at the top to allow water in, but it had not failed at the bottom to allow water out. So the box just slowly filled with water. So when they actually opened it up, water poured out onto their feet, and you could sort of see the corrosion that had happened in there. And so that's what caused this box to fail. And in so doing, that had damaged part of the control system, but the system was designed to compensate if there was an issue in this area, and it would increase sort of the I think it was a flow of a specific pump in that, which caused an additional vibration running at a higher speed, which is what ultimately caused the damage to this pipe. And in the end, the cost of that seal was like $20. Nothing. In the end, the root cause of this was just a failure in a $20 part, and they had spent a couple of $1,000s to replace that pipe the first time it failed. And that's what 5 whys is all about. That's what really our methodology is about, getting you beyond just that surface level of dealing with the symptoms and taking the headache tablet, as I think we talked about 2 weeks ago. Get to that root cause. Because it's usually cheaper and easier to fix the problem at the root cause level. And that's what the 5 whys is for. Okay, so this one, when I do the, when I mentioned, I said that with problem statement, this is the #1 most important thing, is to get the problem statement right. #2 most important thing is to actually get to a root cause. Okay, so this one you can practice not just in your projects, but even in your daily life, just to understand when things go wrong. Why do we think it's happening? And keep asking why until you get something that looks and feels a whole lot more like a root cause, and not just a surface level cause or even a symptom. Okay, that's our 5 whys. Okay, I'm gonna keep moving here. So the improve phase, we're gonna get to do a little activity here in just a second. So how are we gonna solve the problem? There's again some tools around brainstorming to help you come up with interesting ideas and possible solutions. I think I would have mentioned this 2 weeks ago as well. What often happens is I get a root cause out of the analyze phase, and then I think of the very first possible solution for that, and then I go, okay, got it. I got one. Let's move on to the next root cause, without considering there could be many more possible solutions for this root cause. Some of them might be a whole lot better than the first one that I came up with. Okay, so, and some of the tools like ideal, final result, and anti-solution, those are creativity enhancers to help you get additional ideas coming out there. We'll look at 5S in just a second there. There's tools around decision-making to evaluate and pick the best ones. I mentioned those, I think, a bit earlier. And then let's run a pilot. Make sure that it's going to work, these solution ideas. Let's get a plan in place to do that. And that probably involves getting a 2B process map of the future state, either to make the decision to do it, or certainly once you've got it, to train people and make sure they're ready. And then validate, prove that it is actually different, practically, graphically, analytically. Does it make logical sense it's better? Can I make a picture? Can I run the numbers to prove, run the stats to prove that it really is better now versus the original situation we had in measure? And then continue to engage and update my stakeholders. Okay, so we're gonna play with one of the tools, 5S. This is a tool that can be really helpful, not just in the improve phase, but you can actually use this earlier on in the process, even in the measure phase. This is a nice way of identifying some of the quick wins as well. So this is the tool, comes from our Lean toolkit originally. You'll notice in the 5 boxes we have here, there's a word in brackets. That is a Japanese word, because again, this tool was one of the ones Toyota came up with many decades ago. Here. And so 5S is how do you produce an organized, clean, and safe workspace here. So it's a 5-step process that repeats itself. So first of all, sort. So let's look at the workspace that we have here, whether it's a physical one or a virtual one. We do some work here. What is the work that we do here? And what are the tools and equipment and things we need to do that? Anything else that isn't needed to do this work, let's get rid of it. Let's take it out and put it somewhere else. Put it either where it belongs, or if nobody really needs it, just get rid of it. Okay, so let's sort and have the things that I'm supposed to have and get rid of the things I don't need. Okay, now the stuff that I've got left, let's find a home for it. You know, a place for everything and everything in its place. Maybe you've heard that one before. What's the best way to lay this out to make the work here as smooth and easy and efficient as possible? And that's our set in order, straighten. So then shine. Let's make sure everything's clean. Clean and safe and working properly and so on, because it's a lot easier to see when something's out of order when everything is clean. I've got some pictures I can show you for that. And then the 4th S here is standardize. So this work we do here, we may well do the same kind of work somewhere else. We should make our environment here look just like the environment in the other places we do this same kind of work. Okay, so let's standardize it. So no matter where I am, I know I have my workstation set up just in the most efficient way I need it. And then sustain. What will I do to regularly monitor? Are there new tools that have appeared? And if so, do they belong here or do they need to go? And if they do belong here, where should they be? Let's agree as a team, where does this stuff belong? And do this ongoing monitoring and maintenance. If you can do that, you will have a clean, safe environment. Okay, so I'm going to show you some pictures in just a second, but first, we're gonna have our own personal 5S experience. Okay, so I'm about to show you a slide that has a bunch of numbers on it. And I'll give you a chance to do this. This one, I'm not gonna give you an extended time. So let me get my stopwatch going here. You've got 10 seconds to find the numbers 1 through 49 in order on the screen here. Okay, and as it says in the lower left, good luck, because you're gonna need it. Okay, 10 seconds to find the numbers 1 through 49 in order. Okay, here we go. Okay, start. Here's your 10 seconds. You have 5 seconds. And stop. Okay, there you go. That was 10 seconds there. When we do this with a class, we ask people how far you got and so on. I'm guessing you didn't get a whole lot further than 2 or 3. In this one, it's very rare that anyone gets much further beyond that, because this is a mess. It's a mess about it. In fact, I said numbers 1 through 49. I can see stuff in here. There's 68s right in the middle. There's 80 over on. We have numbers here we're not even looking for that are messing up the workspace here, so I can't even find the ones that I need. And that's really what sort's about. So let's take out numbers 50 through 90, because those. Okay, a bit of a mess, but I bet it's a lot easier. I'm sure plenty of you are still looking to find some of the numbers, and that's absolutely fine. I bet it's easier now than it was just a moment ago to find the numbers that you're looking for. And that's what sort's about. Let's get rid of the things that we don't need and keep the things that we do need. Okay, now the stuff that we do have, let's try to put them in order. Well, I haven't actually rearranged them yet, but what I am going to do is let you know that there is an order to the numbers that are here. So if you start with the box that is in the lower right, you will see the number 1 is in that box. And if you move up from that box, so in the middle left, you'll see number 2. And then in the upper left, you'll see number 3. And then if we carry on now, starting from the bottom, but now in the middle, number 4 is in the bottom middle, 5's in the very center box, 6 is in the top middle, and so on. And when you get all the way over to 9 in the upper right, you can start back over in the lower corner in the lower left where number 10 is there. Okay, and then 11's above it and 12's above it and so on. Okay, so actually is a bit of a sequence there. We did this back in January and with a group, you know, most people got just a few numbers in, and another guy's like, oh yeah, I got up to 12. Like, how on earth did you get to 12? Oh yeah, you've seen it before, right? So he kind of knew the trick here. So there is actually some order here that makes it easier to find what you need, and then we can shine it. Let's clean up the fonts and the sizes. Let's have everything be organized the right way up. All the numbers are roughly the same size to make them not other ones standing out so much that they distract you and so on. It should be even easier to now see 1, 2, 3, 4, 5, 6, 7, 8, 9. I just did all of those right there very, very quickly. And then we know how to put numbers in general, and most cultures, we work from left to right, we work from top to bottom. Let's standardize these numbers in the same way that we do numbers other places. And I would imagine that you would have no problem in 10 seconds being able to move your eyes across all 49 of those numbers. And that's the idea of 5S. So sort, get rid of the things I don't need. Set in order. Let's get some structure and organization to them. Where do things belong? Let's shine. Let's get it all cleaned up and looking good. And in this case, with our numbers all right way up and so on. Standardize. And then lastly, sustain. So if I don't keep an eye on this, it would be very easy for it to look like this again, right? If I don't keep an eye on it, and if there's 2 numbers missing here. I'll give you a moment. See if you can figure out which ones they are. Yeah, my guess is you probably don't know. You might have gotten one of them, but it's unlikely you got both. But how about now? It's a whole lot easier now. It's 18 and it's 42 that are missing. When things are clean and organized in order, it's much easier to find the things that are out of place. And that's the idea of 5S. So thanks for playing with me. I hope you enjoyed that. Here are some examples. So these are physical ones, physical environments here. On the left, you can see it's the before and after. The before is above and the after is below in all 3 sets of these here. In the left, we got a couple of buckets here that are just sitting there. And do they belong there? Is there a different place where they should be? And if they do belong here, let's make sure it's clear that they belong there. So below, we've painted not just the space on the floor where they belong, but it's not so easy to see, but there's even a silhouette for each of the 2 buckets so that you know exactly where to put it. Okay, and they've now labeled the space as well. In the middle pictures, I know it's hard to see, but there's a lot of parts and things on the shelves here. And when you go looking for stuff, you've just got to rummage through the shelves and find it. Versus, they now have created a space on the wall where now these parts are all organized. They're labeled. There's 2 main sides based on their thickness of what they work on. It's very easy to see what I need. In fact, I can also see that the part I might need is currently being used somewhere. It's not even on the peg, and I can see that at a distance before I even walk over there. And then on the right, there's a nice example of shine where they've cleaned it up and painted. I mean, the top picture looks like there could be a leak there. We wouldn't even know because it's so dirty there. You'd never realize it. Not that they've cleaned it all up and painted it. If there's a problem there, I will notice it immediately. Okay, and anyone can do 3S: sort, set in order, and shine. It's called spring cleaning, or in some cultures they do pre-Christmas cleaning. That's another one. I don't know what you guys do in India. Could be similar, right? The hard part is the standardize and sustain. Anyone can go clean things up. The difficult bit is having the discipline. And in fact, the word for sustain, I think the Japanese word technically means discipline. There, having the discipline to stick with it and make sure you do the ongoing monitoring. Okay, so just very briefly on control, and then we'll take some questions. So control. So now that it is fixed, how will we make sure that it stays fixed? So can I draw that before after picture, and can I do that with some statistical process control? And I'll talk briefly about that in just a second. Some of the tools are here to help me make sure I'm monitoring the right things, and then I take action as I need to. So what is my control plan to keep an eye on things? How do I respond when I see a change that I'm not expecting? And then I can act on my lessons learned and maybe go back to my scoping tools that I used at the start to identify where am I going to work next. Okay, so just briefly on statistical process control. This is a graph. This is all real data. Again, this is from a project several years ago. Someone gave to me and said, we've got, look at these invoice corrections that are happening here. It's going up and down. What's going on with this process? And I think most of us would look at this and go, oh gosh, at February at the start, we were up almost 100. And then in March, we were at 40, 45 or so. What's going on there? What caused that big drop? Or in July, we were low at one of our lowest points almost there. But then all of a sudden we increased in August and then again in September. What happened there? And then what caused us to drop down in January? It's natural for us to look at these ups and downs and try to find meaning there. That's what we sort of do as humans. Our brains are tuned to finding patterns. Okay, so there's information here, but there's actually not enough information. I could actually put some additional knowledge onto this chart that will help me make better decisions to understand is something really interesting going on here. Should I be worried about this big drop or this big increase that's happening here? I mean, ideally we want zero, so no invoice corrections is the ideal state. We want everything to be perfect, but should I be worried about all these ups and downs? And that's where the principles of SPC, statistical process control, can help us. This is where we use some numbers and some stats and some probabilities to decide what looks different and unusual. And based on the data and the history of how this process is performed, we calculate what are called upper and lower control limits. And these are boundaries that say variation within these lines, that's typical. That's kind of what this process does. It'll never be the same one day to the next, 1 month to the next, whatever. There'll be some natural variation around that. So don't worry too much about that stuff. But anything that goes extremely high or extremely low, that's probably worth paying attention to. And that's what my control limits are helping me to do. And in the language of the stats world, we talk about common cause variation and special cause variation. So the common cause is there's nothing unusual happening here. This is the normal random variation in the process. Every item that goes through every unit, every object that goes through experiences these sources of variation. Then the special cause variation is something weird and different happen. That is not typical for this sort of, that's unusual that you would be so far out. Okay, so if I apply the same, if I apply that thinking to this is the exact same data that we just saw 2 slides ago. The top chart is what you see there. Based on the normal variation in this process, there's actually nothing unusual there. And this tends to have an average of about 55 corrections a month. That's the green line that's in the middle there. And there's variation around that. Sometimes we're above that, sometimes we're below it. I might even go up as high as 114 and as low as 0 or -4 as it's calculated here. I shouldn't be at all surprised that happens. There are other signs of unusual behavior even within the red lines. Like, so if I spend too much time on one side of the green line, that's unexpected. There's other signs of unusual behavior that are there, but the principle is the same. Let's add some stats and some probability to our graph so I can identify, should I be worried about this? And the short answer here is there's nothing sticking out. There's nothing unusual. I have all the tests turned on. This is just the normal random variation in this process. So it's actually okay. Now, we may not like it. We may not like that there's 55 corrections, and I want to bring that down, but I shouldn't be surprised when I see these up and downs. And that's what statistical process control helps me to do, both when I am initially looking at my problem and trying to solve it, as well as when I get to the end here and I'm trying to do the ongoing maintenance, because I can now establish my ongoing measurement system to see the ups and downs that are happening. And I then know when I see a change that's unusual and unexpected, now I can think about doing something. And I don't have to worry about the ups and downs that are just a normal part of this process. Okay, so it gives me some wisdom to be able to know when to take action and when not to do something. And with more information, you can make better decisions. Okay, so that's the idea of statistical process control. Again, in the yellow belt course, and even more so in the green belt course, we drill into these concepts in greater detail to help you understand how you can do this for yourself. The calculations are relatively straightforward here. I'm not going to show you any of the equations or anything like that because it wouldn't matter anyway. But we'll teach you how to do that so you can know how to keep an eye on things and know when to get excited and when you don't need to worry about it. Okay, so that's it. That was a bit of a tool blast there. I know we moved kind of fast through a number of things. We'll go in a lot more structured way through through that. When you go through the yellow belt training, you'll get to see most of these. Certainly all the ones we talked about today. You get to see a bit more of those, and then. Okay, it's the question chat, yeah. And then, of course, as we progress through, once you learn the yellow belt tools, apply them to a project, you'll be ready to start to look at some of the more sophisticated tools in green belt. And then if you decide to make a career of it, black belt and master black belt. So I think we'll come back to just this slide one more time to remind you that these dates are coming and that you can register for this. My colleagues, Ram and Pravir, will be doing the training for this. They're great. There's a lot of experience. I mean, it's good that we've got a couple instructors in here, so you get some diversity of experience and opinion as well happening in there. I find it's always valuable to get the kind of some additional context and diversity and what's happening there with your instructors. And if you do decide to go through this, you'll get a certification from this, both from the university and from GELRAD. And these things matter. These things are helpful in terms of you stick it on your LinkedIn profile, and that will help you. In fact, I regularly see job ads and things like that. They say, we're looking for people who have some kind of certification in this way of thinking and working, because we know what it takes to do it. We know what it takes to use the tools to solve the problem. And it's not always easy to stick with it and apply the tools and bring the stakeholders along on the journey. So if you do decide to do it, it's totally worth it. And I can certainly say personally, getting involved in Lean Six Sigma has changed my life. I've had a very different direction to my career than what I would otherwise have done, thanks to this. And I'm very happy as well as a result. So I think that's it in terms of the content here. I think we can go ahead and take some questions. I never got to show you my thank you slide, so I'll do that now, and then we'll go back to the questions. Okay, so I'm ready when you are for the question.
Any set of tools specifically for industry? Let's say somebody is only from pharma industry. So are there specific tools which are applicable to pharma industry, or is it a generic set of tools?
Sure. Well, it is a broad set of tools. We've done projects with so many different industries and companies. It's the same base toolkit is always there, but if, for example, if I'm dealing with a physical environment, like a physical manufacturing process, I might preferentially use some of the tools that work really well for that sort of situation. So I think I showed you a spaghetti diagram in part one. If you imagine a top-down view of the workspace, and here's where all the equipment is, and here's the path that the process follows to go through that. That tool works really well when you've got a physical space. And so as a coach, I might recommend, given the problem we're trying to solve, let's draw a spaghetti diagram. Excuse me, if I'm working on the invoice problem statement that we saw earlier, I don't think a spaghetti diagram is going to help me there. I probably am going to pull out a Pareto chart. Let's start look at the reasons why there was an issue, why we needed to have the credit note. I'll probably use that sort of approach rather than something like the spaghetti diagram. So, so there aren't, I wouldn't say that these are the pharma tools, these are the finance tools and so on. I wouldn't say that. The methodology is very broad, and then that's where the coach helps you to work out what's the best tool for the situation and the problem that you're trying to solve.
The next question, hello. Dave?
Yes.
Yeah. The next question is the Lean Six Sigma methodology, do we have any stage where we can estimate the cost of the improvement project to take approval from the top management?
Yeah, sure. So that can get done at multiple places in doing the project. In fact, when you first get started and do, as I mentioned even today, the is-should matrix, it's a way of brainstorming possible problem areas to focus on. You can capture these and then do some evaluation of them based on benefit and effort. That is a very common way of doing. Sometimes people call it the B&E matrix, benefit and effort matrix, or the tool generically is called the filtering matrix. How can I filter out some options? If you can put some numbers to that, you can even make a guess at the start. I think this product here is more important than this one over here because it's going to be worth more in terms of the cost savings or the time savings and so on. So you might do that at the beginning just to get the idea of what product we're going to focus on first. And then as you go through, when you get to the measure phase, for sure we want to validate that we really were right in terms of how bad we thought the problem was, both to get the extent and then what's the impact. So was it really 2.3 million euros in lost margin from the German customers there, right? So if we can validate those numbers and get that cost support quality, when we get to the improve phase, further along, I can then evaluate my solution options in the same way. What is it going to cost to implement this in terms of time and money? And then how much removal of the root cause will I get? What's the benefit that I'll get from that? So there's actually multiple places in there where you can apply that thinking around cost support quality. What does it cost when we have defects and have mistakes and have failures? And that allows the leaders to make better decisions about which products to do in the first place, or even should we continue. There was a product that a colleague of mine coached years ago where they thought there was a problem with, it was telephone bills. And they got in and they got the data. They thought that the telecoms provider was overcharging them. And they thought, oh, this could be worth so much money. They got in and they found out that in the end, we were getting overcharged by about 1.5% on some accounts. And then we were getting undercharged by about 1%. So the net increase was only about 0.5%. So that's still, it was a big company. So that's still a not insignificant amount of money, but it was not the huge, gigantic problem that everyone thought it was. And so they noticed when these problem mistakes happened was typically around the annual price change. So they resolved that and then pretty much closed the project. And that was it. And so that was there was not a huge benefit financially that came out of that, but what it did do is it made blood pressure go down. So, okay, we don't need to worry about that anymore. We're not getting overcharged. It's actually okay. And there's actually another product I'm coaching. I won't tell the story about it. There's another one I'm coaching now that fits in the same category where, we've been working on it for several months now. Looks like it's not really that much of a problem. Now that we've got the data to prove that, that is still a successful project because now we validated that we don't need to worry about that. So there's a lot of different ways you can go about doing that and tools and concepts that we covered to help make that possible.
Yeah. The next question is, given a time, organization would like to go ahead with the complete cycle of the Lean Six Sigma project. But in today's scenario, in many of the cases, it found that we have a short of a time. Most problems are on the fire. So is there any way by which in a short span of time, we can do some improvement using the Lean Six Sigma tools and concepts?
Yeah, for sure. So yeah, if things are on fire, you need to grab a fire extinguisher and make sure you get the right one for the kind of fire it is, right? And then put the fire out. And then later we can work out why it actually was happening. So yeah, if you're in that situation where time is of such an essence, we talked system 1 and system 2 at the very start of the first webinar 2 weeks ago. You probably have pretty good ideas, and most of them will, at least to get the fire stopped, is probably the right thing to do. You can still use some of the tools and the thinking. It doesn't take long to use the tools. Sometimes there's a perception that using the tool will make you go slower. But I think I said at the start of this one, the purpose of the tools is to make you go faster. So you actually get a better result and you go faster. So you can have an unstructured conversation for an hour, or you can have a structured one for half an hour, and then you're done and you can move on with executing. So a lot of the tools are there to help speed you up to do that. So apply the thinking that goes with the tool, make your best guess based on the information that you have, put the fire out, and then if you can, come back to it and do the 5 whys thinking. Sometimes I got to just go put a new bulb in and carry on so I can make dinner, and then later I'll figure out why the bulb was broken in the first place. But you can still use the mindset that goes with it. Let me understand what I'm doing as I do it before I just launch into some solution idea.
Yes, thank you, Dr. Neela Yagnik and Mr. Dinesh Panchal for doing all this hard work to arrange this webinar series. This was the 3rd one. And I hope that people were able to get some good basic understanding of this very powerful methodology and how important it is, some idea of tools and concepts. And obviously the next step is now we're looking forward to giving more detailed ability. So not just having a general idea, but actually being able to practice Lean Six Sigma and apply it to their daily work life, including some yellow belt level projects. That would create tremendous results. And we look forward to having a chance to work with folks and teach them in the yellow belt workshop that's coming up. And I also thank the participants. Thank you for spending your time from your busy schedule to be with us today. And I wish you all good luck.
And on behalf of Navrachana University, I wish to thank again Dave and Pravir, Ram, Elaine for spending so much of their valuable time for all the 3 webinars here over the last 3 Tuesdays. And thanks to all of you participants too. I can see that many of you have attended all the 3 webinars. So thank you for attending. And on, as Dinesh has mentioned, on 26th of August, we will start the detailed management development programs in this field. We'll send you more communication, more mails on that particular session. So do join us even on 26th of August, and have a nice day. Thank you.